back to another video on our Statistics and Data Science series. Today we are going to be talking about tidy data and the tidyverse in R. So before we get into the coding, let's talk a little bit about what tidy data is. So you may think it's just a really nicely organized, clean data set, sort of there, but here we're using tidy in a more technical sense. So there's a number of rules that a data set needs to follow for it to be considered tidy. So we define tidy data as data where each column is a variable, each observation forms a row, and each cell is a single measurement. So while the definition of tidiness is really an attribute of the data set, it also depends on what we want to do with the data. So it depends on our plan for whether we want to analyze, summarize, or visualize our data. I'm going to put some visualizations on the screen from Allison Horst. I love these. I think they summarize why we want to use tidy data so well. So the standard structure of tidy data means that all tidy data sets are alike, but a messy data set is messy in its own way. So when we're working with tidy data, we can use the same tools in similar ways for different data sets. Whereas when we're using messy data, we're often using one-time approaches and we can't really reuse the same tools across different data sets. So it makes it hard to iterate or reuse these methods. So the Tidyverse is sort of a meta package full of a bunch of other packages that are involving tidy data. And they make it really easy to do sort of common analysis and common data visualizations within R when we're working with tidy data. Two of these, if you've been following along in this video series, we've already seen. So we've seen ggplot, which assumes that your data is tidy, and dplyr, which also assumes your data is tidy or can be used to get your data in a tidy way. So let's get right into it and hop onto RStudio and get coding. Before we begin, let's load in the Tidyverse package. If you don't already have this installed, please install it first by going install.packages and then in quotations, Tidyverse. Then run your library command to load in the package into R. We are going to use an artificial data set called grades_long, and I'll explain why it's in long format in just a minute. You can get this code on the website that's going to be linked in the description of this video. Okay, so let's take a look at actually the full data set here, because it's not that long. We essentially have different students and subjects, and we're looking at their scores before and after some intervention. So in this example, we're looking at grades before versus after active learning was incorporated into lectures. Again, fake data. So we have one row for every person, every student, every time, every subject, and every score. So this is in long format. This data set technically is tidy in the definition of tidiness. But for what we may want to do, which is analyze this data, say longitudinally, it might not be tidy. So in many cases, we're looking at data with repeated measurements over time longitudinally. So we have times before and after within the same person. Sometimes we actually want one column for each time point. Depends on the analysis, but let's assume that we do need that. So here, our data is not tidy given our analysis plan. So what we want to do is make additional columns, one for the time before and one for the time after. So we're only going to have one row per student. We can actually do this by what we call pivoting in R. And in the Tidyverse, I believe it's in the tidyr package, we have a function called pivot, wider and longer. As the name of this original data set suggests, this is long format, but we want to condense the number of rows, we want to reduce them, and expand on our columns. So we're shortening the data and we're making it wider. So that's why we're going to use this function called pivot wider. Let's call pivot wider on grades_long. And then we are going to pivot. So again, let's just take a look at the head first couple rows and get the names of our columns here. We want to make new columns for the times before and after. So instead of just one time column, we want time before, time after, and we want the grades in them. So this is where we're actually going to take our names from. So we're going to get our names from time, and we want to fill in the values of score. So we're going to get our values from score. And if we were to run this, you can see that we now have two columns involving grades, one for the before and one for the after. Whereas previously, we had two columns per student and subject and only one column of scores. So now we have one for math, one for science, one for math, one for science, and so on. Just to show you that we can also edit the names of these columns, I'm going to add a names underscore prefix, and I'm going to call it scores, just to show you that we can actually change those column names to scores before and scores after, just to make the data a little bit more readable. So there you have it. We've just pivoted our first data frame from long format to wide format. If we wanted to save this data set, we should assign it. So maybe we'll call it grades underscore wide. I like to format my code just a little bit neater. And one more thing that we could do is actually utilize the pipe from dplyr. So instead of calling grades underscore long here, let's just pipe it in. So we could say grades underscore long, and then we are going to pipe it into the pivot function. Clean this up if we want, just so it's a little bit more readable. And I'll add a comment here that we're just editing the new column names by adding scores in front of it. So here, we now have a new data frame, grades wide, and it's the exact same as before. So we're utilizing our pipe. We no longer have to say that first argument is the data set because we were piping it in. We're calling the pivot underscore wider function, and now we have a new data frame called grades underscore wide. Now let's say that we want to plot the grades data, but we only had the wide version, so the one that we just created. This might not be as easy to plot as in the long format when we're using ggplot2. So let's see if we can actually pivot grades underscore wide back to its long format. So let's do this as an example together. Again, let's utilize the pipe. So we are going to take grades underscore wide, and we are going to pipe it into a new function called pivot underscore longer. Very similar to pivot underscore wider. So pivot underscore longer takes a couple of pieces of information. The columns that we want to expand into more rows, we put into the calls argument. And here, that would be scores before and after. So we want to take those and put them into the rows and make it into just one score column. So here we have two, so we're going to need to use that C function to say, hey, I actually have multiple values here. It's a vector, but we can still list them. So scores before and scores after. The next argument that we should call is names2. And this is where we want to save that information from the previous column. So we had one column for time before and one for time after. We need to be able to distinguish between these two columns in the new rows. So here, it's the time. And then we have values too. So we've created a new column that distinguishes between time. And now all this data here is going to be combined into one column. What do we name it? Well, those are the scores. So let's call this and see what happens. We have almost the exact same data set, only we have different names for before and after because we had added it previously. But if we look at this and grades long, it gives us almost the exact same information. The only difference being instead of before and after, it's called scores before and scores after. And the ordering of the columns are a little bit different, but we know how to use dplyr, so we can change those easily. I'll just add some comments here. So these are the columns we want to reduce. Name of new column to store information from calls. and then the name of the new column, storing the values. That's as simple as pivoting wider and longer gets. Now there are more advanced examples of pivoting wider and longer, and you can find a couple of those in the lecture notes. So that's it for today's short example. I hope that you found this useful. Let me know if you have any questions, and I'll see you on the next video.